Okay. Okay. So now we see for just now, okay, a quick review on what we discussed just now. Okay. Okay. So just now we discussed the introduction to the SPSS. Yeah, got data view and variable view, and then also we can do data analysis using the analyze, yeah, the menu, yeah, in the menu bar. Okay. Okay. So, and then we also discussed the basic idea of the multiple linear regression, where the dependent and independent all must be metric, okay, or scale. Yeah. Okay. And then we discuss R square, adjusted R square, and then F test, yeah, T test, yeah, interpret the beta coefficient, okay, and so on and so forth. Okay. So any question you want to ask, yeah, for the discussion just now? No? Yeah. Okay. So if not, now we see dummy, yeah, dummy variable. Okay. So we still use the same data set. Okay. Okay. But now we can put in one variable. Yeah. Okay. We still use the same model like just now, but we put in one variable called dummy. Okay. So we see how to do it. Okay. You can do it here. X20. Okay. It's okay. Can also, yeah, X20. Yeah. Okay. So you can put in the label, you can put in there here X20, yeah, dummy, yeah, dummy variable. Okay. Okay. Means what means for the normal case, we do setting in the variable view and then key in data in the data view. But of course, let's say you copy data from the Excel, yeah, you copy data in the data view and then do some editing, yeah, in the variable view. Okay. Now you see for the values, yeah, you click here, make sure you get this pop-up box, yeah, value labels. Okay. So here can be for urban, yeah, can be location, the location of the respondent, either in urban or maybe semi-rural. Okay, rural maybe not much. Maybe the business activity maybe not much, but let's say one for urban, yeah. Okay. No. One and then urban like this. Lowercase also can, not a big problem. Yeah. Okay. Value you put one label is urban. One for urban. Yeah. Zero for semi-urban. Yeah. Okay. Okay. Means for dummy variable, you cannot use 1, 2. Here must be 0, 1. Okay. So that is okay. Okay. If no question, then just click okay. Okay. So if no question, okay.
So,
Here
so that means
yeah,
automatically the ruler is the default, right?
no, we need to consider rural. We assume that the respondent all in urban or semi-urban. That's it. Okay.
So okay, only two status
Only
and
two categories. Therefore, only one dummy enough.
oh okay, 0 is not considered. One is a dummy, right?
So one dummy. Okay, let's say got two categories, one dummy. Let's say got 4 categories, 3 dummy. Always -1.
Okay, so
Okay.
Yep.
Okay. So later we are going to see you will get two variables, two equations. You get 2 equations. Just now only one. I mean for the morning section, the first section, we only get one equation. Now we're going to get two. Okay.
Okay.
Semi-urban, one equation. Urban, one equation. Okay. We see. And then the measure change to scale. Okay. Scale. Yeah. Okay, done. So this is done already for the variable view. Okay. So now go to the, if no question, you go to the data. Please you key in data. Yeah. You see here got 100 respondents. Okay. 100 respondents. We of course we create a new variable already here. Can I see 20? Yeah. Before we key in manually the first 50, yeah, 1. Yeah. Okay, the first 1 until 50, 1. Okay. In this area, I think Excel is better, more powerful than SPSS. Okay. So here SPSS must do it one by one. Okay. 1 until 50, 1. Yeah. And then 50, 1 above 0. Okay. Can I see? Yeah. Okay. Okay. If you give it another 10 seconds. Yeah. Okay. So now we continue. Yeah. Okay. So we done already the dummy. So what we do, we can do testing. Yeah. Okay. So analyze, regression, linear. Okay. So remember now, x20 is dummy. X20 is dummy. Okay. So now analyze, regression, and then linear. Okay. So we use the same model like just now, but now we add one more dummy. That's it. Okay. So therefore, x17 is the dependent. X17 still dependent, same like just now. But now we add one more variable called dummy variable. Okay. So technical support, and then the delivery speed, and then dummy. Okay. 6, 16, 20. Okay. Now we got three independent variables. 2 is a normal one is a dummy. The dummy is a bit special. Aslam is Aslam. Mike. Okay. So if no problem now, okay. So now we can just click OK. Yeah. To get the output. Yeah. So like this. Okay. Okay. I give you 10 seconds. Make sure you get the same the output. Then we can continue with the interpretation. Yeah. Okay. Okay. So now we see, if no question, we can continue to do the interpretation. Yep. So we see the output now. So for this one, actually, of course the value change, yeah, because you add in one more dummy. But how to interpret still the same like just now. Okay. How to do F test still the same like just now. Okay. But can you see? Okay, want to highlight one more thing, only the degree of freedom. Yeah. So now here got three, because got three independent variable. Yeah. For the residual, the DF 96, because 100 minus K minus 1. For now 96, because 100 minus 4, we get 96. Okay. The total is still the same because it's 100 minus 1. Okay. Therefore, here still significant because p value is very, very small. Yeah, even smaller than 5% or 1%. Okay. So okay. So if no problem, now we see the coefficient. Yeah. Okay. So now we see the okay, here again. So zero is for urban. So one is for urban. Yeah, one is for urban. Okay. One is for urban. Yeah. Zero. Semi-urban, zero. Yeah. Dummy. Yeah. Okay. So okay. For this part a little bit different compared to just now. Now we see this now. Okay. So because we got two categories. Yeah. This variable we got two categories. Therefore we got two equation. Yeah. Now. Okay. Okay. So for the it's okay. We see first the basic one. I mean from the output. Yeah. How to write out the equation from the output still the same. Then we see the semi urban and also the urban. Okay. So we should get this y equals to 3.064 and then plus 0.075 x6. Okay. 0.916 x16 here and then minus 0.234. Wait. 234 x20. It just should be okay for you. Yeah, okay. From the output. Yeah, okay. Okay. So if no problem, now we see the difference between the semi-urban and also urban. Okay, now. Okay. So we see for semi-urban, the dummy is 0. Okay, for this term is 0. Therefore, the semi-urban means x20 is 0. Okay now. Dummy is 0. Therefore, the x20 is 0. Therefore, this is the equation here for the semi-urban, the 3.064 plus 0.075 x6 plus 0.916 x6. Done already. This is equation for the semi-urban, for the respondents from semi-urban. Okay. That means maybe their shop, yeah, okay. Their shop is in the semi-urban area. Okay. Okay. So and then for the urban, we get this, yeah. 3 pen 3.064 x6. Sorry, 16 here 16. Okay. 0.916 pen another pen. Okay, x16 and then minus, yeah. So minus 0.236234, yeah, 2341. You can see this is the equation, yeah, for the urban respondents, yeah. Everything the same, but when you see x 20, you change it to 1, yeah, for the urban. Okay. Yes, correct. Okay. Yeah. Therefore, we can simplify it a bit more. Yeah, 3, calculator, not 3, it's not 3. 2 point something. Wait, sorry, 3.064 minus 0.234. Yeah, we get 2.83. Yeah, and then plus 0.075 x6, 0.916 x16. Okay, this is the difference between the semi-urban and the urban. Only the intercept different. The rest all the same. Okay. Okay. Is there no problem? Okay. If no problem, now we see a little bit more. Okay. Therefore, in general, you can say that the urban respondents, they feel that they are not too satisfied with the service and also product by this company, because the intercept is quite small compared to the semi-urban. Different is the intercept. Here 3 point something, here 2 point something. Okay, and let's say you want to interpret the. Okay, see one example on how to interpret the coefficient. Yeah. Okay. Actually, it's the same for the. It's the same for the what for the beta coefficient. Yeah. Only the intercept is different. Okay. So anyhow, we can discuss a bit. Let's say you see 3.064. Yeah, with the rating for delivery speed, technical support, delivery speed, the rating for technical support. Okay, at least means you must put in semi-urban, otherwise not correct. Yeah, means this value 3.064 is correct for the semi-urban area only. Okay. Okay. But if you want to interpret the intercept or the constant, okay, intercept and constant same thing. Okay. So let's say you want to interpret the constant in the urban, for the urban, therefore, like this, 2.83. Yeah. So here you change to 2.83. This is 2 point. 2 point. Okay, 2.83, and then this is for urban. So that's it. Yeah, for the dummy. Okay. This is how you can handle the dummy. So this dummy for this example is what? Is the urban, is the location of the shop, their business. Okay. So you can handle this by using COVID and non-COVID. Okay, and also another one, financial crisis, non-financial crisis, or maybe company. Yeah, finance company, financial related, it's a bank, insurance company, or finance. Yeah, financial related and others. There are two groups. Okay, like that. Okay. Okay. Any question for the dummy? Yeah.
So I don't know why when I run the output, it's a bit different.
Your data point same or different? You see the data point you key in
I
1
follow
until 50. Okay.
I follow exactly what you told.
Okay. Show me your output. Yeah. Now. Okay. Show me in the chat box.
Okay.
Let me see how. Yeah. Not this. This one not too important. The coefficient. Yeah.
Right, right.
Okay. How come your output same with this now? Did you include the dummy in the testing?
Yes, I include it. Let me show you.
Okay, show me the coefficient table. The coefficient table.
Coefficient table.
No, you did not put in dummy. Can you see? Okay. You see your coefficient table, no dummy. For me, I put in dummy. Therefore different. Okay, you see, I got dummy in the here. X20.
Let me try
Okay.
again. Let me try again.
Okay, try again. Okay, now I answer a question asked by another student. Yeah, can eat. Yeah. Okay. The significant level of dummy is more than 0.5. So therefore here is not significant. You can see 0.02, no 0.2 something. Therefore it's not significant. It's larger than 0.05. Therefore we cannot reject the null hypothesis. Okay, so therefore the dummy is not significant. Therefore, we still interpret like what we interpret the p-value, the beta coefficient just now in the morning section. The same method. Okay. Okay, this is to answer. Yeah. Okay, can eat. Yeah. Okay. Okay.
So, sir, just to check one more case.
Yeah.
Yeah. Now, if we include another category of, let's say, a rural area, so what should we do in the table, and what should we change?
Okay. 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 Now we do this now. Yeah. Okay. One more. Yeah. Okay. So now we see the data. This. Yeah. So okay. So now we modify a bit. Let's say here we put in D1 because now got two dummy. If you change a bit, X20 D1. Okay. Okay. So X20 D1. Now we put in one more category. Therefore, we call it same. Got three. Now we got three. Yeah. Okay. Now we got three. Okay. Where is it? Okay. Okay. So for D1 equals to 1. Therefore, for what? For urban. Now we change a bit. Okay. Okay, and then 0 otherwise. Okay. And then D2 equals to 1 for semi-urban. Okay. And then 0 otherwise. Okay, we do it now. Yeah, okay, like this. Therefore, okay. Okay. Before we got 3 situations. Yeah, we got 3 situations. Okay, we do it now. Yeah. Okay. The first respondent, second and third. Okay, we just see what 3 examples. Okay. So D1 and then D2. Okay. So let's say for the first respondent, I think I increase the font size. Okay. Let's say for the first respondent, yeah. Yeah, okay. D1 is 1. The rest must be 0. Therefore, you know this respondent is from urban. Okay. Number 2 can be 0, 1. Therefore, this respondent from semi-urban. Okay. Let's say 0 and 0. Therefore, respondent 3 from rural area. Okay. Any question? So therefore, location or area may be better. Yeah. So this is urban. Yeah. Semi-urban.
So dummy, we can only use either 1 or 0, right? There's
Yes,
not like
correct.
0, 1,
Correct.
2, 3.
1 0.
Oh.
This is correct.
Okay,
Only
so
1 0.
So you have to create more columns if you have more elements.
Yes, you are right. You are right.
But it's k minus 1.
Yes, correct. You are right. Correct. Thank you.
Okay. So in can be 0, 1, 2, 3. Okay. Then okay.
Cannot. Because if you put in 0, 1, 3, 1, 2, 3, you're not going to get the 3 equations. So by doing so, we can get 3 equations.
Yep. Okay.
Okay.
Yeah.
So okay already.
I'm clear. I'm not sure for others.
Okay, it's okay. So we just finish this part. Don't worry. Okay. So like this. Okay. So we see okay. Okay. So we are here. So now x20 is x20. Okay, we change it to D1. Okay, D1. Okay, and then now we got one more is D2. Yeah. So D2. Okay. So D1 is for what? Urban. D1 is for urban. Okay. So D1 is for urban. I think this one no need, not too important. Yeah, you can also use this. Yeah, because this is not categorical. It's dummy. Yeah, it's dummy. Therefore, this one actually not too important for us. Yeah, you can delete also. Yeah. Okay. Okay. So now D1 is urban. Okay. D1 is it? No. Yes, correct. D1 is urban. Okay. So therefore, we see the data. D1 is urban. Okay. So therefore, we no need to change. Therefore, 1 until 50 urban. Okay. 1 until 50 urban. Okay. Done. Okay. So now D2 must be 0. You see, you cannot be 1 1. Okay. Therefore D2 you put in 0. Okay. 0 means not urban. No. Yeah. Correct. 0 means not no. D2 because the respondent 1 confirm already is urban. Okay. Therefore, they cannot be 1 and 1, must be 1 and 0. Okay. So respondent 1 until 50 urban. Okay, here's 0. Okay. 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 So now 51, now we got 30, we assume got 30 respondents, yeah, from the from D2. D2 semi-urban, yes, correct. Okay, therefore 1 for this. Okay. So 30, 30 respondents from semi-urban. So until 80, yeah, correct, until 80. Okay, done lah. Okay. Okay. So the rest are all 0. Therefore, you know, this 81, respondent 81 is not urban, not semi-urban. Therefore, confirm must be rural. Okay, logic. Okay. So therefore, 81 until 100 from rural. They shop in rural area. Okay. Okay. Any question? Yes. No. Okay. So if no, now we can run the equation. Yeah. Again. Okay. Okay. Good question. Okay. You are right. You are right. You are right. Yeah. Because the it's not significant, therefore not much meaningful. In let's say for capstone, if not significant means not much meaningful to explain too much. But now we assume it's significant. Yeah. Okay. Yeah. Okay. And then you see your second question. The dummy's assumption is both mutually exclusive. Mutually exclusive. Correct. If one respondent have two property, yeah, this method would be yeah, correct. You are right. You are right. You are right. So must be mutually exclusive. You are right. So of course, by logic, the area either can be classified as urban or semi-urban. It cannot be both urban and also semi-urban. You see? Okay. Okay. So you are right. You are right. Yeah. So must be mutually exclusive. Yeah. So but we can define properly. We can define properly that that area belongs to each category. Just like we can define which period is considered pandemic. You see, we can follow some authorities. The authorities are definition. Example, COVID may follow the WHO. Okay, and then financial crisis may follow some important economies. Yeah. Okay, they say financial crisis ended, or the war in Russia, Ukraine already ended. We follow that some experts idea. Okay, okay, like that. Okay, so okay, yeah, it's a good point. Yeah, thank you. Okay, so we continue. Yeah. Okay. So yeah. Okay. So now we got two dummy to represent three categories. Yeah. Okay. So three different areas. You know, we do now. Yeah. So still the same like just now. But we got two dummy now. Yeah. Analyze, regression, and then linear. Okay. So now you put in. It's okay. You reset first. Reset is faster. Okay. Reset. And you put in the satisfaction, and then dummy D1, D2, technical support, and also technical support, and then the delivery speed is independent, independent variable. Okay, and then click OK. Okay, so therefore, okay. Okay. So therefore, to interpret other things all the same, but only this one a bit different. I'll show you now the coefficients. Means from here you should be able to get three equations. Okay, we do it now. Okay, so we got three area: urban, semi-urban, yeah, and rural, yeah. Okay. Okay. So now we got three. We should get three equations. Okay. So at the beginning, we write out first the general equation. Yeah. Y equals to. You use this one. Okay. So 3.348 0.065 x6. Okay. 0.911 x16. And then negative. Yeah. Eraser. Okay. Okay. So minus 0.443, your D1. Okay. And then minus 0.349, your D2. D2. Okay. Okay. Now we see again what we defined just now. Okay. So D1 is urban. Yeah. D1 equals to 1. Yeah, is urban. Yeah. So D1 equals to 1 is urban. Okay. Therefore, D1 equals to 1 is urban. Yeah. But D2 will be 0. You can see D1 is 1, but D2 is 0. Okay. Before we get this. Yeah. 348 0.065 x6. 911 x6. No, 16. Okay. And then minus 0.4431. We remove this term. Yeah, because D2 is 0. D1 is 1, D2 is 0. Okay. Yes, correct. Okay. So after that, yeah, therefore we just do a calculation. We take this one minus 0.443. Okay. So we get 2.905. Yeah, the rest all the same. Okay. So like this, we can get three equations. Okay, because two dummy variables, we got three different situations. Okay. Okay. If no problem, now we see next. Next will be semi-urban. Okay. Okay. So for semi-urban, yeah, semi-urban is when the D2 is 1. Remember, D2 is 1. Yeah. Therefore, this is 0. Okay. So 3.348. No, we just straight away can do, no problem. Yeah, it's easy. Yeah. So we just do the calculation. We take the constant minus 0.349. Yeah. 3.348 minus 0.349. Yeah, we get 2.999. Okay, the rest all the same. Okay, so this is the equation here for the semi-urban. Okay, so for the rural, remember for the rural, D1, D2, 0. Okay, D1, D2, 0. It's D1, 0, D2 also 0. Yeah, therefore just copy the first three terms. Okay. Okay, so done already. Okay, this is the how to how to write down the three equations from the dummy, from the two dummies. You need three categories. Okay.
So I just found one observation.
Yeah.
So just now we just this add on one more dummy, and then other data like the X16, X6, D1, we don't change anything. But I saw that the significance level for D1 improved from just now was 0.232 to now 0.88, 0.088. So just introducing then it changed some significant levels.
Oh, it's by chance. It's only by chance because we don't know the actual data. Can I see? We don't know the actual. I simply artificially do like that. Just by chance they improve. Yeah, but maybe they become worse. Can I see?
Yeah, some become worse, but some improve quite a lot. Yeah.
This is by chance actually.
Okay.
Okay, so if no problem, now we done already. The dummy. Okay, we see. Yes, any question?
For this 51 to 80, why we need to put one? Is it sample?
You're talking the data, is it? Okay.
Yeah.
Which area?
From 51 to 80.
81 to 80? No, 81 to 100, is it?
No, 51 to 80 because we have 30 sets.
The D2. The D2.
Okay.
Right.
Okay. You're talking this part. Okay. Yeah. All right. Why?
The one. Why we need to set to one? Is it 30 sample for sampling?
Yeah. Okay. You can see back this table. Can I see? Yeah. Because we have two dummy variables, the combination here must be different. 1 0 0 1 and then 0 0. Okay. They cannot be 1 1. Can I see? Can it be 1 1? 1 1 means the area is urban, also semi-urban. Does it make sense for us? Okay.
I think
so,
sir just
because it put okay for the pen. Okay, the first until 50 you put in 1 0 means urban. Yeah, and then semi-urban 51 to 80 semi-urban. Yeah, therefore D2 1 means this semi-urban. Yeah, okay. Okay, but let's say 0 0 means the area is not urban and not urban, not semi-urban. Therefore it's rural. Because we got three categories. Use two columns, two variables, two dummies to represent the three categories, three different categories.
saying what you say is I mean this is that example. You can use a 51 to 71 and
Yeah.
It's just an example.
This is for illustration purpose. Yeah. Okay. Because okay, that's it. Yeah. Okay. Because let's say everything 1 0 and then 0 1, we cannot see the three category. Okay. So yeah, therefore therefore 150, 51, 80, 81 until 100. Yeah, like that. Okay. Okay.
Sorry, sir. Can you go back to your data set again?
Yeah,
I noticed your variable for D2 is using nominal instead of scale.
yeah, good question.
Will it have any impact to our analysis?
Good question. Okay, you can see again. Yeah. But since you can get the output, I think no issue. But anyhow, yeah, good question. Yeah, you see it now. Yeah. Okay. This time did not change. Yeah. Sometimes cannot get the output. But just not get the output. Okay, we change to scale and then do again. But I think different not much. Yeah. Okay, we do it now. Yeah. Okay. Okay. Same thing, is it 443, 349? Same, no change.
Same.
Yeah, same thing, no change. Okay. But sometimes cannot get the output. Maybe it's a new version, maybe, I'm not sure. Okay. Okay. Yeah. Okay. no question. Now we see. Yeah, we go back to the slide. We
Sorry, sir.
ask now. Yeah.
Yeah, may I know what is the objective of we doing this kind of dummy? So how do we moving forward to use the equation? I mean, in practical, what's the usefulness of having this equation?
Oh, dummy. Okay, good question. Yeah, thank you. Okay. So okay. So okay, we see here first. There again, we can see the another example. Okay. So therefore, we see the behavior. From here, we know the behavior of the respondent in rural and semi-urban different. So means the rural area, they feel they are more happy with the service and product given by the company because it's higher compared to semi-urban. Based on this result, can you see? So urban, rural. Yeah, correct. Urban is one more, yeah, correct. Urban only 2.9, yeah. So but rural is the highest, yeah. So 3.3 something. Can you see? Okay. So means at least from let's say from no bias, just from this equation. Therefore, you know maybe the it should be more careful or more send more experienced people to serve the your customers in the urban area. And see this is how you can apply in some particular issue. Okay, because maybe they are more choosy. Let's say a bit slow, they are not happy like that lah. Something like that. Okay, so this is for this case. Okay, in the practical sense. Okay.
Okay, so we are just splitting each of the category and then to test their satisfaction,
Yes, correct,
by
correct.
Okay, thank you, got it. Yeah.
Correct. Okay. So another case. Another case, you can also handle. Okay, you see the more recent, okay, more practical case, yeah, COVID. Okay. So you may put during the pandemic is one. Okay, let's say non-COVID. Example, let's say COVID end at this example. Okay, end at 2022 December. Let's say WHO announced, yeah, end of the pandemic, let's say end of 2022. Okay, so means they actually last from December, right? Started December 19 until December 2022. Okay. Therefore, if you get monthly data, yeah, you can do the December 19, 1. Until December 2022, still 1. But January, okay, January 2023 will be 0. Means no more pandemic. Okay, means not considered true critical illness. Example. I don't know yet. Okay, so we all don't know. Okay. So starting January 2023 will be 0, and then even before also 0. So you see, this will be it's very important event that affect almost everybody, including business. Okay, so therefore the performance of certain company maybe will change during COVID and non-COVID. Can you see? So for some company maybe different not much, but some company, let's say tourism, confirm they affected a lot. Right? Therefore, you will get two different equations. Okay, you get two different equations. One is for COVID, one is non-COVID. Okay, so therefore, you can do some comparison. Okay, so first thing. The second thing, when you do some planning or development in the future, you should see what is the situation. Let's say COVID coming again in 2025. Therefore, you should refer to the COVID equation, not the non-COVID. This okay, some practical issue. Yeah, like that. Okay. Okay. So if no question.
So some question.
Yeah.
So is it common to use this multilinear regression to treat this category input? I mean, we treat. I mean, put in like a dummy yesterday I think you say that maybe sometimes we use the logistic regression, right, for this kind of category.
Okay. Good question. Question. So, it depends on situation. Yeah. For some study, let's say your study cover the COVID period, but you want to handle, therefore you know COVID is important, you want to handle this. Therefore you consider this as the independent variable. Okay. But let's say your data, okay, yeah, independent. But let's say your data only cover, let's say this year, 2022, only this year. You get daily share price data. Therefore, you no need to use dummy. Because we know this year still affected by by COVID. Okay. So therefore depends on the situation. Not always use dummy. Yeah. Okay. And then logistic is a different case already. Logistic, yeah. Logistic, the dependent variable is binary. Okay, now different thing. The dummy, the independent, yeah, is what they call yeah, it's dummy must refer to the independent, not dependent. It's 0, 1, yeah, for certain event, yeah, for the categorical variable. Okay, now different.
Okay.
Yeah. Okay. So now we come back the okay. Okay. Yeah. So okay. So this is the design. Yeah, design about yeah, for the multiple linear regression. Okay. So at least we discuss some general and also dummy case. Okay. So can I say dummy is independent? Be careful, it's independent. Yeah. Okay. So nature of the independent variables can be both fixed and also the random. Yeah. Okay. So the independent can be fixed, also random. Therefore, must be very careful. Yeah. Example. Yeah. Let's say for the time series. Okay. For the time series data, some variable is fixed, some variable is random. Example. Yeah. Random is easy. Example, the return on asset for a company, it must be random. Yeah, we even cannot predict. Okay, correct. The return on asset for certain year is difficult to predict. The return on asset. Okay, therefore it must be random. But for sometimes it's fixed. Example, the land size of a country. You see, normally no change for many years. I know sometimes change, yeah, sometimes change, but in general no change for many years. Let's say Malaysia, correct? Since 65, yeah, no change anymore, always the same, yeah. Okay, and then for the company, this one of course is qualitative. The HQ of a company normally no change. Okay, Maybank, correct? The HQ still in the Menara Maybank, near to the in the center of the town. Okay, so therefore must be careful on the either fixed or random. Yeah, fixed means not too good. Okay, not too good. You want something, some variation. Okay, yeah. So means don't use lane size. Okay, as your independent variable like that. Be very careful. Okay. Okay. Any question is? If no, we see next. Yeah.
Hi, sir. I do have a question. I'm still a bit confused on the usage of this multiple regression. So I just pasted a photo on the group. So if let's say I have a set of data where I have few variables that are categorical, and I wanted to run this MLR. So
Wait.
I have to.
Wait. What's your data again?
My data consists of a few categorical variables, for example, like gender or education level.
Okay.
So if I want to run MLR on this set of data, so that means I have to label the gender and also this education label into the dummy, is it? Like 0101.
Okay, good question. Are you saying that all these are independent?
Yes, these are all independent.
Okay. Okay. What is your objective?
So I wanted to, I will also have a dependent variable, for example, like maybe salary or whatever. So I wanted to see the relationship.
What's your dependent?
The dependent, let's say salary.
Okay. 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 Okay.
Yeah. So my confusion is that according to this chart, right? If I want to use this MLR, the independent variable has to be metrics, right? But right now, both gender and also education levels are non-metric.
Okay. So you but not too good. If you want to do multiple linear regression, not too good because not encouraged. You have to put in too many dummy. Not too good. Yeah. Okay. 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 Education level. But I mean let's say only one variable, you got one variable got few categories, still okay, but not too many. Not too many variables. Okay. So you may consider to use multivariate ANOVA. Yeah. Okay. But we're not going to cover this in this module. Okay. Okay. Are you going to do this in your capstone?
No. It's just a random question that I just thought of. So we are only recommended to use this when the independent variables, the count of labels in each of these independent variables are small. Is it like just 2 to 3 labels?
No. We encourage to use this multiple linear regression when the data are mostly metric. Yeah, metric. Let's say you've got one variable, one independent variable is few categories. You can use dummy, like what we discussed just now. Let's say you got one, your dependent variable is binary, binary dependent. Yeah. Okay, it's binary. Means 0, 1. You can use logistic. Okay. But not few categorical variable. You can see. Yeah. Example, one dummy, the rest metric still good for this. Okay. Yeah.
All right. So in our assignments, when we look for the data set, it's better to look for those independent variables that are metrics, right?
It's correct. No, actually, not say better. It must. Okay. Based on assignment,
Okay.
yeah, it must use all must be metric in your assignment. Yeah. Okay. Yeah. Okay. So if no question, now we see. This one is saying they did not change too much. Yeah. Can you see? They did not change too much. Once in a while they change the HQ, but not always like that. Okay. It's not always. Okay. I mean for the mapping. Yeah. Okay. 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 Now we continue. Okay, you're still here. Yeah. Okay. Okay. So this is the sample size consideration. Yeah. But of course, it's a guideline. And then let's say you're doing some project for other company, you must or your own company. So you should just follow the data. Yeah, using the existing the data. Okay. I mean what means, let's say they give you 1 million observation, just follow. Okay, just use. Okay. And then you can do the testing, you can do subsample. okay, to make sure that the result actually is convincing. Okay, this is a guideline. If you are starting to collect data by your own using the questionnaire. Okay, so we see. Okay, simple regression can be effective with the sample size of 20, yeah, but not encouraged because even FAP in FU minimum also should be 100. Okay, this FAP, your master should be more. Yeah. Okay. So you should maintain a power of 80, 0.8 in the multiple regression. Okay. So minimum should be 50. So better 100. Can I say 100? Okay. The ratio is 5 to 1. The day got one student asked me about the parsimony. Yeah, therefore 5 to 1. Yeah. Okay. So this one variable. Yeah, for 5 observations. 5 to 1. Okay. So let's say you got 100. 800, therefore, can be 20, yeah, can be 20 variables. It's still okay. Okay, this minimum. Okay, but prefers 15 to 20. Okay, let's say 500 over 20. No, let's say 600, therefore 30. 600 over 20, therefore it's 30. So means your observation 600, you can have 30 variables. Okay. And this will increase when you are using the stepwise. The stepwise estimation means yeah, discuss a bit just now. Yeah, you will see this. I think maybe after lunch. Okay. Any question just now? Okay. No. Okay. So if no, now we see. Wait. Maybe got question. Okay. If no, now we see next. Yeah. Okay. Therefore, again, the degree of freedom higher means it's better. Okay, they will improve the generalizability. Yeah, so means you, therefore it's more convincing. Means you can generalize your study, yeah, to other other field. Let's say you are analyzing it for the banking industry in Malaysia. Therefore, you can generalize it to other country also. Okay, if your degree of freedom is more higher, means the result will be better in general. Result will be better a bit. Okay. Okay. So and also we can discuss a bit just now. Yeah. Okay. So remember 100 minus a minus k minus 1 is the df. Yeah. Okay. Df, you got many formula. Different situation, different formula to compute the df. This is for the ANOVA. Okay, this now. ANOVA is under the regression. So remember when your k increase, yeah, your k increase and df drop. You see, 100 minus 3 minus 1, you get 96. When you have 3 independent variable, df 96. They say only 2. Therefore, df will be higher, okay, 97. Okay, so maximize df. Yeah, df should be high. High is better. Okay. So yeah. So we done already for this part. Any question? Yes. The line no good, is it? Oh, okay. I think the line just now not too good. Okay. But I think so. This, I mean, just now discuss until here. So therefore, in conclusion, the F should be high. High is better. Okay. Any question? Yes. For this. Okay. So if no, so see you in a short while. 1:30. Yeah. 1:30. We continue. So make sure you use the SPSS. We supposed to discuss the stepwise. Okay, stepwise regression. Okay. For 1:30. Yeah.
Okay, thank you. See you, sir.
Thank you. 1:30.